So let's have this problem. So to complete this table by converting the given values to z-score and find the area. So take note that this is the formula for the z-score. So we have the given values minus the mean over the standard deviation. So for this given, to convert the score to z-score, so we have the x value is 31 minus the mean 17, then divide by the standard deviation, that's 5. So we have 31 minus 17 equals, then divide by 5. So the z-score is 2.80. Then for this given, to convert to z-score, so the x value is 73 minus the mean, that's 81, over the standard deviation, that's 6. So we have 73 minus 81 equals, then divide by 6. So the z-score is negative 1.33. Then for this given, to convert to z-score, so the x value is 2.56, then minus the mean, that's 1.7, then divide by the standard deviation, that's 0.3. So we have 2.56 minus 1.7 equals, then divide by 0.3. So the z-score is 2.87. And for this given, so z equals, the x value is 35 minus 43, then over the standard deviation, that's 4. So we have 35 minus 43 equals, then divide by 4. So the z-score is negative 2, or negative 2.00. So since we have now the z-score, so we can find now the area using this table. Now take note that for this table, the area is between the mean and the z standard deviation, and the mean is the center of the curve. So for this z-score 2.80, so since this z-score has no direction, then we're going to find the area to the left. So the area to the left, so for this 2.80, so let's assume this is 2.80 in the curve. And again, using this table, the area is between the mean and the z standard deviation. So we have 2.8, then 0.00, that's 2.80. Then you connect. So the area for 2.80 is 0.4974. So this area is 0.4974. But since we're looking for the area to the left, so this is the unknown area, and this 0.4974, only this area. And take note that half of the curve, the area is 0.5. So therefore, to find the total area, we just need to add these two areas. So we have 0.5 then plus 0.4974. So the area for 2.80 is 0.9974. Then for this negative 1.33, so let's assume this is negative 1.33. And again, to find the area from the mean to this z standard deviation. So just ignore the negative. So we have 1.3 and this is 1.3. Since we have this 0.3, so look for 0.03. So that's 1.33. Then you connect. So the area for 1.33 is 0.4082. So this area is 0.4082. But since we're looking for the area to the left, so this is the unknown area. So on this case, since away from the mean, so therefore to find the area, just subtract this 0.5 minus the given area, that's 0.4082. So again, if the area is away from the mean, then you need to subtract. But if the area is within the mean, then you need to add. So for this negative 1.33, the area, so that's 0.5 minus 0.4082 equals, so the area is 0.0918. Then for this 2.87, so let's assume this is 2.87, and to find the area from the mean to this 2.87, so we have 2.8, then 0.07, that's 2.87, then you connect to find the area of 2.87. So the area is 0.4979. So this is 0.4979. Then again, we're looking for the area to the left. So this is now the unknown area to the left. And observe that the area is within the mean, or the mean is part of the area. So we need to add. So we have this 0.5 plus the given area, that's 4979. So the area for 2.87 is 0.9979. Then for this negative 2.0, so let's assume this is negative 2. Then to find the area with the mean, so we have this 2.0, so just ignore the negative since 0.00, so this is 0.00, so the area of negative 2 is 4772, so this is 0.4472. Since the area to the left, so observe that this area is away from the mean, then we need to subtract. So this is 0.5 minus 0.4472. So 0.5 minus 0.4472. So the area for negative 2 is 0.0528.